we start with the next topic, which is spectrum. Now, I think we all have done spectrum till class 10. Can someone tell me what exactly is a spectrum? Or a basic spectrum that we have all seen. एक spectrum जो हम देखते हैं usually अभी rainy season चालू है तो we see a rainbow. Rainbow is a spectrum of white light made up of how many colors, people? 7 colors. तो ये एक spectrum होता है. Today we need to understand कि how is a spectrum formed, what are the different types of spectrum, and what we are going to study is atomic spectrum. ठीक है, वो सबसे important part from an exam point of view से हमें पता करना है कि what is a spectrum. चलो, पहले let's understand basic. So this is people white light. ये I think 10th standard में आप लोगों ने किया होगा. इसको एक और बार थोड़ा refresh करते हैं. This is white light, and we know that people white light is made up of different wavelengths. So lambda 1, lambda 2, lambda 3, lambda 4, and so on. ठीक है. Now, when light goes from a denser medium to a from a rarer medium to a, what happens? Light bends. ऐसा आपने पढ़ा है, right? So ये जो dot बनाया है, that should have been the trajectory of the ray, trajectory of light. But does it follow that trajectory? No. क्या होता है? It starts to bend. And what is this angle called as when light comes out in the form of the different wavelengths? और इसको हम बोलते हैं spectrum. Yes, and that theta is called as what, people? The angle of deviation. ऐसे कुछ पढ़ा था? नहीं पढ़ा है तो भी that is fine. This is called as the angle of deviation. Yes or no? Now people, this angle of deviation theta, or how much a light will bend, that theta depends on the energy of that particular wavelength, of that particular light. And we know the formula, E is equal to H nu. Energy is directly proportional to frequency. So if theta is directly proportional to E, then it is also directly proportional to frequency and inversely proportional to wavelength. Getting that? So which light will have the maximum angle of deviation? The one which has the minimum wavelength. I don't know if you're getting that. For example, we wrote visible light ka spectrum, Vibgyor. When we were doing wave nature, we wrote about the electromagnetic spectrum. What was lambda for violet color? 3800, 3600. And similarly for red light क्या लिखा था हमने? 7,600, somewhere around 7,600 angstrom. Yes or no? So which light will bend the most? The one which has the smallest wavelength. Did you people understand that? Yes or no? Chalo. So on a new page, please write down spectrum. We'll first write a basic introduction, then ये diagram copy करना है. The phenomena of splitting off a beam of light. The phenomena of splitting off a beam of light into radiations of different frequencies, and patterns obtained after dispersion is known as, obtained after dispersion is known as spectrum, is known as spectrum. Next point. When light coming from a source, when light coming from a source is dispersed by a prism, when light coming from a source is dispersed by a prism, light of different wavelengths are deviated, light of different wavelengths are deviated by different angle of deviation. By different angle of deviation. Now people, you can copy the diagram. Now we continue with types of spectrum. Now people, there are two types of spectrum. The first type that we have is called as emission spectrum, and the second type that we have is called as absorption spectrum. Okay, we'll understand each emission as well as absorption in detail. Emission further gets divided into two types: continuous and discontinuous. Discontinuous further gets divided into two types: atomic spectrum, or it's also called as line spectrum, and the second type of discontinuous spectrum, we don't have this in scope, but this is, you can also say this is molecular spectrum or band spectrum. The most important part in this is the atomic or line spectrum. Now let's start with the first type. What exactly is the meaning of emission spectrum? As the word suggests, emission. Now let's say I have a particular gas, let's say you can take hydrogen gas, heated to a very high temperature. Now that gas, in this case hydrogen, will release wavelengths of particular frequency, a particular wavelength. So it will emit light, and the same thing, when this is made to pass through a prism, this gets divided into light of different wavelengths, lambda 1, lambda 2, lambda 3, and this particular is the spectrum, or we call this as emission spectrum. I repeat, so I have a gas heated to a very high temperature, it will release radiation which is made to pass through a prism. The wavelengths that you get out from that prism is called as its emission spectrum. Now where we observe this is actually called as a spectrometer. हम spectrometer में उसके spectrum check करते हैं, and we'll study this in detail when we study atomic spectrum. Now this spectrum is of two type. First वाला क्या बोला people हमने? Continuous spectrum. What exactly is a continuous spectrum? A simple example for that is rainbow. Now when you see a rainbow, do you see all the colors? Do you exactly see Vibgyor? Or do you see like they are faded into each other? हमको faded दिखते हैं. Do you exactly see all the colors? No. Now the reason for that is in a continuous spectrum, the difference in the frequencies is very small. So it's like almost all the colors are present, and hence it's like they blend into each other. It's very difficult for the human eye to distinguish between two colors if their frequencies or if their wavelengths are very close to each other. And what happens in a rainbow is all of these frequencies are present, but they are so close, it is very difficult to separate them with the human eye. इसलिए we see as if watercolor में जब the colors have blended into each other, a rainbow looks like that. Now that's called as a continuous spectrum. But what happens in a discontinuous spectrum or a line spectrum, जब हम उसको पढ़ेंगे, is you see colors which you can distinguish between each other. आपको individual color दिखता है in a discontinuous spectrum. Did you people get that? Yes or no? We'll study this in detail. सबसे पहले please write down types of spectrum. Quickly copy this for me. Yeah. You will please write down continuous spectrum. Continuous spectrum. When there is no sharp boundary, continuous spectrum. When there is no sharp boundary between two consecutive wavelengths, or lines between two consecutive wavelengths or lines in a spectrum, then we say that it is a continuous spectrum. For example, rainbow. Next point, the difference in two consecutive wavelengths or frequency is very small when compared to the difference between their angle of deviation. Which two is very small when compared to the difference between their angle of deviation. Which two is very small. And hence it is very difficult to distinguish between the two consecutive wavelengths on the screen. very difficult to distinguish between the two consecutive wavelengths on the screen. Wavelengths on the screen. Next, write down discontinuous or line spectrum. Discontinuous or line spectrum. When there is a sharp boundary, when there is a sharp boundary between two consecutive wavelengths or two consecutive colors, when there's a sharp boundary between two consecutive wavelengths or two consecutive colors, in the spectrum process, we get a line spectrum or atomic spectrum. We get a line spectrum or atomic spectrum. Now we've already done this, but let's do this again. Why do we get a spectrum or why do we see color? So let's say people, we have a gas and we're going to heat the gas. What are we supplying gas? We're supplying gas with energy. Let's say we supply that energy in the form of a photon. So remember, let's say this was the electron in the first orbit and people were supplying energy in the form of a photon. Photon ka energy is given by the formula E is equal to h nu or is hc over. So remember, the photon will have a characteristic wavelength, or you can say that the photon has a characteristic frequency. This photon will come and collide with the electron. When it collides with the electron, it will impart energy to the electron, and the electron jumps from, let's say, N1 to N2, lower energy level to a higher energy level. What was this process called as? Excellent. This we called it as excitation. Then eventually, will the electron stay over there? It has to come back. What was that process called as? De-excitation. And when that when that electron comes back higher energy level to lower energy level, what happens? It again releases that photon. Now people, when that photon is released, will it have the same characteristic wavelength or frequency which it had? No, because some amount of energy got utilized in the transition. So this here has a different wavelength, or it has a different lambda. Let me tell here. And if this lambda lies in the visible range of the spectrum, then we say that, or we can see that on the screen. But it can lie in the visible range or in any other part of the electromagnetic spectrum. Usually UV or infrared ke bare mein hum padhenge. Did you people get that? Yes or no? And we're going to study about emission spectrum. So we're going to study about de-excitation, when the electron is jumping from a higher energy level to a lower energy level. Did you people get that? I repeat, this is the nucleus, You can make these different energy levels. And हम क्या बोलेंगे? Let's say this is 4, 3, 2, 1. So the electron can jump from a higher energy level to, remember this one was called as ground state. Then 2 will be called as the first excited state, second excited state, so on and so forth. Or it can again come from, let's say n is equal to 3, or from here. Are you people getting that? Every time this transition is taking place, it will release a photon which will have a characteristic wavelength which may or may not belong to the visible range. Did you people get that? Yes or no? And for that we study what is called as the hydrogen spectrum. So people, we start with the ground state. Okay, this is ground state, the state which is closest to the nucleus. यहाँ पे n का value क्या है people? This is 1, and this is also called as ground state. Ground state के बाद क्या आता है? So this can be called as the first excited state. N will be equal to 2. I repeat, this is called as the first excited state. Can someone give me the energy level of the ground state in terms of electron volts? Excellent. Minus 13.6 electron volts. What will be the energy in the second state?
Minus 3.4.
Lovely. Minus 3.4 electron volts. What's the gap? 10.2 electron volts. In short, I want to excite the electron from ground state to excited state. कितना energy supply करोगे? 10.2 electron volts. Did you all get that? Yes or no? Now, take it ऊपर. This is n is equal to 3, or we call this as the second excited state. Can someone give me the energy over here? Approximate will also do. Minus 13.6 upon 3 square z square over n square. तो कितना होने वाला है people ये? Minus 1.9 ones are 946, approximately 1.5 eV. What is the difference here, people? How much is the difference over here? 1.9 eV. The reason we are understanding the difference is, what was the gap between the first and second line? 10.2. What's the gap between the second and the third line? The gap is 5 times less. Actually, the two lines should be 5 times closer to each other. But हम उतना बना नहीं सकते. The diagram will look very congested. बहुत भीड़ भड़ाका हो जाएगा वहाँ पर. I don't know if you people are getting that. And if I keep going up, what will happen to the lines? They have to keep coming close to each other. ठीक है, but उतना close नहीं लाएंगे, थोड़ा diagram अच्छा दिखने के लिए. But these lines will keep coming close. How many are done? 3, 4, 5, 6. एक और बना देते हैं. हे भगवान. Six. And people, here we can go till infinity. N3, N4, N5, N6, 7, and here it is. What does infinity mean? That the nucleus no longer has a hold on the electron. With me till here? We are doing emission spectrum. What does emission mean? That the electron can jump from a higher energy level to ground state. When it does that jump, it releases that photon might be in the visible range of the spectrum or might not be in the visible range. वो अभी आगे हम पढ़ेंगे. It can jump from a higher energy level to a ground state, higher energy level to ground state. This keeps on happening, and lastly it can go from infinity to the ground state. With me till here? The first series that we get here is called as Lyman series. So all transitions from any higher energy level to the ground state, the band or the spectrum that we get over there, that series will be called as Lyman series. With me till here? All the photons in Lyman series lie in UV region. UV stands for ultraviolet. Okay? Now, they all came to ground state. Up they all can come to the first excited state. When an electron transition takes place from 3 to 2. Okay? You get the first visible color in hydrogen spectrum, and that color is red. With me? When the second transition takes place from 4 to 2, you get the second color. Ayo. And that second color is, people, green. I have to remember these colors because they can ask specific questions. कि green color का transition बताओ, कहाँ से कहाँ the electron transition हुआ तो आपको green color मिला. ठीक है? Next, the third transition from n is equal to 5 to n is equal to 2. People, इसमें violet कौन सा होगा? Or closest to violet that we have? Third color that we get is violet. And the next color, the next transition is, though doesn't look exactly वैसा, but blue. And there are subsequent transitions from higher energy levels, but they don't show color. So the second region where you can actually see color, this region is called as Balmer, and this is the only visible part of hydrogen spectrum. Did you people get that? Okay. Why is this so important? For example, what is the sun made up of? Helium. How do we know that? Sun पे गए थे? No, right? You get light, you see its spectrum. That tells you what particular, wherever that source of light is coming from, what is that made up of. Spectrum is like thumbprint. We all have unique thumbprints. Every element in the periodic table has a unique spectrum. Actually, there are multiple elements in the periodic table which got discovered because we got a different spectrum. उनसे उनका discovery हुआ. What we are getting here is hydrogen का thumbprint. So किसी source से और उसका spectrometer से अगर हमने उसका spectrum check किया, and if we get these colors, we can say with confidence that that particular element is hydrogen. So Lyman, Balmer, for all transitions in the second excited state. This is called as Ashkin. For all transitions in the third excited state, or n is equal to 4, is called as bracket. For the next second, third, fourth excited state is called as fund. And there's one more which is called as Humphrey. All the other lie in infrared region, infra to deep infra. What you get over here is called as hydrogen spectrum. Did you people get that? Excellent. So people, on top we have rainbow or continuous spectrum. This is what we are saying. Can you distinguish like each color? No, this is like they blend into each other. Okay? Because the frequencies are very close. It's very difficult for the naked eye to distinguish. But what do you see hydrogen spectrum, people? क्या दिख रहा है? हमें सिर्फ 4 लाइन दिख रहे हैं. Rest everything is black. Because there's part of the spectrum which belongs to UV and infrared, not visible to naked eye. और हमने बोला था ना, in Balmer series you get those 4 colors. This is emission spectrum. So hydrogen, when excited, will only emit 4 visible colors. Yes, and something in infrared and in UV. And there's something called as absorption spectrum. We'll study about absorption spectrum, but I want you to understand, see, where there is a line in emission, there's a black in absorption. What that means is, you will absorb only that wavelengths which you emit. Let me give that. See, in emission spectrum, you heat gas to a high temperature, उसके बाद वो wavelength release करता है जो prism के through गया, divided into different wavelengths which we can see. Absorption में हम उल्टा करते हैं. You take the same gas, उस पे light डालो, it will emit everything except the wavelengths which the absorbed wavelength will be exactly the same which it emits. That is called as absorption spectrum. Did you people understand? Simple terms, we see they are negatives of each other. जहाँ पे डार्क था वहाँ पे use C color because वो colors emit हुए because hydrogen doesn't really absorb them. Any questions still here? Yes or no? So we know that in hydrogen spectrum, which are the different series? People give me all the series once again. First series कौन सा है people? Lyman series. What about the second one? Balmer. The third one, Ashkin. Next, bracket. And एक और लिखते हैं fun. For Lyman series people, the transition takes place from all higher energy levels to the first level. I repeat, all higher energy level matlab from the second level or third or fifth. To which level people? First. What happens in Balmer? Second. From where? Third, fourth, fifth, sixth, and so on. What happened in Pashkin? 4, 5, 6, 7. Bracket 5, 6, 7, 8. 2 where? And fund 6, 7, 8, 9. 2 where? And which region do they belong to? Give me the region, someone. सबसे पहला UV. This is in visible region. And what about these? They all belong to infrared to deep infrared. Any questions still there? Yes or no? We have to derive the wave number for hydrogen spectrum. Chalo. Derivation is really simple. Can someone give me the formula for energy? Energy of the electron in Bohr's orbit. What was the formula? Minus 2 point into 10 raised to minus 18 into z square over. This is hydrogen atom. So z का value क्या रहेगा people? So energy in the nth orbit is minus 2.18 into 10 raised to minus 18 into 1 upon n square. The electron is transitioning from n2 to n1. Let's say this is n1 and this is n2. यहाँ से electron यहाँ आ रहा है. So what will be the energy in the n1 वाला orbit? Minus 2.18 n1 square. What will be the energy in n2 orbit? Minus 2.18, and this will become what people? N2 square. Find the difference in energy for me. That is delta E will be En2 minus, how much is En2? Minus 2.18 into 10 raised to minus 18 into 1 upon N2 squared minus 2.18 into 10 raised to minus 18 into 1 upon n1 square. When you open this, this minus into minus is going to become plus 2.18 into 10 raised to, कुछ कॉमन दिख रहा है, 2.18 into 10 raised to minus 18 अंदर 1 upon n1 square minus 1 upon, and this delta E can be written as hc by lambda what was the value of h into c, h कितना था 6.626 into 10 raised to minus 34. How much is c upon lambda is equal to this, so what do you get 1 upon lambda from here, 2.18 into 10 raised to minus 18 upon, इसको मल्टीप्लाई करके कितना आता था into 1 upon n1 square minus 1 upon, when you solve this you get 1 upon lambda is, इसको डिवाइड करेंगे तो we get 109,677 1 upon n1 square minus 1 upon, this is the formula for hydrogen atom. 1 upon lambda is also called as what? Wave number. So the formula for wave number is nu bar is equal to 1 upon lambda is equal to, this quantity is called as RH. RH stands for Rydberg's constant. What is the value of Rydberg's constant? 109,677 in terms of centimeters, or 1.1 into 10 raised to 7 meters into Z squared, because we will derive this for hydrogen like atoms, 1 upon n1 square minus 1 upon n2 square. Remember, whenever you're doing it for numericals, n2 will be greater than n1. That completes hydrogen spectrum. I wanted to then later copy this, and next class we'll do numericals on these. ठीक है?